Hello, Math 113. I know some of you might be struggling with problems like this. What I really want to talk about is the tangent of alpha plus beta. And let's do this problem to express. Now, the main issue may come in rationalizing the denominator. Typically, books don't require you to rationalize these big denominators, but when we're doing this homework online using the Blitzer textbook, they do. So I want you to see this for this particular problem, and maybe it'll help you get through. So notice, first of all, we have tangent of alpha is -3/4, and alpha lies in quadrant 2. So over here on the left, I'm going to draw an angle in quadrant 2, and then I'm going to come down to the x-axis to make it a right triangle, and I'm going to use the fact that tangent is either opposite over adjacent or y over x to label my sides. So I have 3 for my y value and -4 for my x value, and using the Pythagorean theorem we get 5 for the hypotenuse. And remember, this is the angle alpha, and I'm also going to draw a picture for beta. Notice it says beta lies in quadrant 1, therefore I'm going to draw an angle in quadrant 1. Always come back to the x-axis to get a 90-degree triangle, and then we use the fact that cosine of beta is defined to be adjacent over hypotenuse, or you could say that is x over r, and so my adjacent side is 5. That doesn't look like a very good 5. Let me fix that. You just keep going. My adjacent side is 5, and my hypotenuse is 6. And so we have to find the y value right here. To do that, I'm going to use the Pythagorean theorem. So we know that 5 squared plus y squared is equal to 6 squared. When I simplify that, that's 25 plus y squared is equal to 36. When I solve for y squared, I subtract 25 for both sides to get 11, and then I take the square root of both sides to get plus or minus the square root of 11. And depending on what quadrant we're in, we know to use either the positive or the negative. Well, since I'm in quadrant 1 and y values are positive in quadrant 1, that is the square root of 11. So now I'm ready to use the formula for tangent of alpha plus beta. And so you have tangent of alpha plus beta. You know you're supposed to memorize this formula. So memorize for all the sum and difference formulas for the test. So that's tangent of alpha plus tangent of beta divided by 1, and if this is a plus, then that sign changes to a minus, tangent of alpha times tangent of beta. And now we're just going to plug in. I am going to scoot over, though, a little bit for the space. I'm still probably going to have to go on another page to finish this problem. So remember, this is the alpha picture on the left, so we're going to use that information to fill in for alpha, and then on the right is my beta triangle. So tangent of alpha, remember it's opposite over adjacent, so that's -3/4, and that value was given in the problem also. So you can either use your triangle or the given value, plus tangent of beta. Now that value was not given, so again that's opposite over adjacent, so that's going to be square root of 11 over 5, okay? And then divided by 1 minus tangent of alpha is still -3/4 times tangent of beta is square root of 11 over 5. I'm going to work to the right. Now, to combine my fraction together in the numerator, I need a common denominator. So what I'm going to do is I'm going to multiply to get a common denominator, which means I multiply 3/4 by 5 over 5 because the common denominator is 20, and square root of 11 over 5 by 4 over 4. I'm going to do that to the right, and I'm going to go ahead and write that as a single fraction. So we now have 20 in the denominator, and the numerator, that's going to be -15. That comes from the 3 times 5. Now, I can't multiply square root of 11 times 4, so the best I can write is 4 square root of 11. And then divided by, and I'm going to simplify this denominator down here too. Now these two negatives here is going to make that a plus, so that's 1 plus 3 square root of 11 over 20. Don't forget, when you multiply fractions, you multiply both numerator and denominator. It's easy to forget when you're working with these. All right, Now, once again, I need a common denominator because I have to add this together before I can invert and multiply. So 20 over 20 times that 1. And I'm going to come over here to the right and continue. So in the numerator, I have negative 15. I don't want to lose that. Plus 4 square root of 11 over 20. And in the big denominator, I now have 20 plus 3 square root of 11 over 20. Now, I know you can see this happen, but I'm going to write it anyway. I'm going to invert this entire denominator down here and multiply. Okay, now that gives me negative 15 plus 4 square root of 11 over 20 times, did I leave myself enough room? 20 on top when I invert over 20 plus 3 square root of 11. Now, I know you see what happens. This 20 and this 20 cancel. And now I'm going to go to another page to finish this up. So after canceling those 20s, this is what we have. Now, I'll tell you, in older textbooks, and even older versions of the textbook you're using now, they left the problem just like this. But the online homework wants you to rationalize, and I can't get rid of that portion of it, just because you can imagine programming. And so what we're going to do is rationalize. It's probably good for you. So I'm going to multiply both the numerator and denominator. Remember, this is going to be by the conjugate of the denominator. So what is the conjugate? Well, this is the denominator, and the conjugate means you change that sign to rationalize. So it's going to be 20 minus 3 square root of 11, and I'm going to multiply that same value on the top and the bottom. Now, what does that really mean we're doing? Well, y'all, we're going to have to FOIL all this out. So think about this as a binomial, and this is a binomial, and we're going to do first, outer, inner, last. Same thing with this denominator. So let's get going. So negative 15 times 20, pull out your calculator if you need to, but that's going to be negative 300. Okay. Negative 15 times negative 3 square root of 11. Now remember, when you multiply, you can multiply numbers times numbers and square roots times square roots. So this is going to be plus 45 square root of 11. Okay, now I'm doing 4 square root of 11 times 20, so I can multiply the 4 times 20 together to get plus 80 square root of 11. And then finally, I can multiply 4 square root of 11 minus 3 times negative 3 square root of 11. That's going to give me negative 12, so number times number. And square root of 11 times square root of 11 is 11, right? Or you can say it's square root of 11 squared, which is 11, or you can say it's the square root of 121, which is also 11. Now let's do a similar thing in the denominator. So 20 times 20, I'm doing FOIL, right? So first, 20 times 20, that's going to be 400. And then I'm going to do outer. So 20 times negative 3 square root of 11 is negative 60 square root of 11. Now I'm going to do inner. So 3 square root of 11 times 20 is going to be plus 60 square root of 11. And then last, 3 square root of 11 times negative 3 square root of 11 is going to be negative 9. That's not supposed to be read. I apologize. So that's negative 9. And then square root of 11 times square root of 11, remember, is just 11. No more square root. Why? Because it's the square root of 121, which is 11. Now, what I want to do is simplify that as much as possible, and that's going to be my final answer. So negative 300. I got like terms right here in the middle. 45 square root of 11 plus 80 square root of 11. You add the 45 and 80 to get 125 square root of 11. Okay, and then minus 12 times 11 is going to be minus 132 divided by, now what happens in the denominator, this is nice, is negative square root of 11 and positive square root of 11 cancel each other out. And that's what happens when you multiply by a conjugate. So that denominator trick right there should happen every single time you rationalize a denominator that's a binomial like this one is. So 400. And then we have minus 99, okay? If I keep going to the right to simplify, just for space purposes, negative 300 minus 132 is going to be negative 432. And then plus 125 square root of 11. And in the denominator, 400 minus 99 is 301. Now, that is the final answer for this problem, but there's something I want you to look for. If this number, and this number have common factors. So let's just say that 2 divides into all 3 of those numbers. It doesn't. You would have to do that to simplify. And it needs to be the biggest common factor, so a greatest common factor. So just like when you simplify the quadratic formula, it's a very similar thing here. These in green do not have any common factors, so what I have rectangled off there is the final answer. So you have to do this sometimes with big numbers like this one in this section, and I hate that for you. I think it's good numeracy practice, but really it seems to be above and beyond what other textbooks have done, but it's good for you. So try not to bark about it too much. If you do have questions, please let me know. Shoot me an email, give me a call, come to the math lab, and otherwise have a great day.